Okay, so now that we have our shades made, this isn't quite interesting enough. I have a better idea. What if I want my shades to change in intensity? Maybe the larger the window, the deeper the shade. The smaller the window, maybe it doesn't need to be quite so deep. So how would I adjust that? Well, right now, without even thinking about it, we were applying the exact same offset vector to every single panel. If I wanted to apply a different distance to each panel, we get back to our data tree structure. So let's use this remap attractor values. We're just going to copy this whole chunk and use this code again. So let's bring it up to where we were. So these values, when they come in here, are meaningless. All they are is for every single panel we have a different value associated with it based on its distance to that attractor curve in this case. So I'm going to use this min and max, this remap function, to change that into something that's more meaningful. So if I want my minimum shade to be, say, 1/2 foot, and my maximum to be, let's make it extreme so it looks cool, 5 feet, and I'm going to keep the clip at 0 because I know these values are all between 0 and 1. Okay, this now has translated all those attractor values into values that make sense, and in this case what they mean to me is, I can use a little number container, these are my shade depths. So if I plug this in, rather than having them all be 2 feet, now it's going to be a whole bunch of numbers. Now notice it froze. This is likely going to happen to all of you very often, where you're just going about your work and you accidentally misalign your data trees. So it took a long time. Notice this was 6 milliseconds before. Now suddenly it takes almost a second for each one. Very often you could plug this in and it might take an hour for it to compute because it's going to be building 50,000 facades all at the same time, and it'll look like it's frozen and you'll have to restart. It's very, very frustrating. So it's important to always be aware of your tree structure. So let's take a look at what went wrong here. And let's investigate that with our param viewer. So bringing this back. So something's weird here because I know it's taking a long time because I have my profiler on, and I can see that I have a billion shades per panel. So something's odd. So with debugging, everyone has their own strategies, but I would recommend don't assume anything. The whole nature of a bug is that something is working in an unexpected way. So I always start at the end, wherever I can tell there's a problem. So if I know, even though I expect the problem to be maybe down here, where I input something, let's start at the end where I see that I have an issue. So if I pull this into param viewer, it's going to say that I have 143 branches, but I notice I have also 143 items. And if I put this into a panel, sorry, if I hover my mouse over the S here, notice it says I have 20,000 values. So rather than building 2 shades per panel, which I would expect to give me about 300 values, I have 20,000. And that's because I have 143 shades at every single branch. So if we go backwards now, this input looks correct, right? I have one item, one corner each. Same here, 142 numbered branches, 143 total with one each. That looks good. Hover over B, notice it looks different. This should always be the warning to you that the branches are different. That's probably what's causing the issue. So let's follow that one back. Okay, it's coming from my move command. And I hover over this and I see that, yep, that's the problem. G looks good. One item per branch, as expected. Now here is where the error lies. I have one long list of 143 values. So this data tree does not match this one. Let's look at them directly. So if this is what's coming in on one side, and this is what's coming in from my newly changed vectors, because I have 143 items, and we mentioned how the tree structure helps you reuse components. It allows you to loop over and over again. That's how we're able to have one little bit of code repeat itself for every single panel. Well, what this is accidentally doing is every branch, it's going to repeat this section where it grabs that, so it has the point, it's going to move the point and then build all these surfaces. But in this case, rather than moving each point once, I gave it, what's this, 143 different depths that it could have been. So for every single panel, it offset it 143 times, creating 143 items, or 143 shades once it cascades through the whole script. So I want to change that to match this data tree. Now here's where we can remember how to use and manipulate data trees in order to get this to align. So looking at this, one thought is I have a lot of zeros and that's pretty confusing. So, and I'm going to do this in a separate side. So I'm going to create a vector. So rather than just manipulating and testing here while it's plugged into everything, now this only takes 2 seconds, but it could be taking 20 seconds. That could take a long time. So while this is all live, several ways of going about this. I would either encourage you to shut off everything. It's almost like you're doing maintenance. You want to turn off your electricity before you start playing with the electrical outlets. You can disable all of these things. Or in my case here, I'm going to just create a new vector and manipulate this. So the first thing I'm going to do is simplify. Now notice simplify didn't work. That's because the simplify command only knows that some of these branches are extraneous if they have if there are multiple branches. But if there's only one branch, it has nothing to compare it to. This is quite frustrating because simplify doesn't always work as well as you like because it's not able to shrink down single branches. I could flatten, which solves the problem. There again, that's the atomic bomb. It just destroys the whole tree structure and says, cool. This works, but it can have problems down the road. So I would recommend against using, or just at least be cautious about using that. Another thing I'm going to show you guys here is something called trim tree. So in this case, I know that this code is always, for one reason or another, giving me these 4 sets. So if I use trim tree, it's like flattening, but you get to carefully control it. So if I plug this in here, let's take a look. Notice it went down 1. And as it shows in the image, you're kind of pruning the tree. You're just chopping off the edge. So right here it says 1. If I were to change this to a larger number, I can shrink it even further. Now if I go too far, it's going to freak out and break because I try to trim it too far. So there's another component called shift paths, and I believe that this is actually and shift paths safely. And I know that this is actually a custom component. Off the top of my mind, I'm not sure whose package this is a part of. It may be part of Grasshopper now. But if you find it, shift paths safely will always allow you, if you try to do it too much, it won't allow you to do that. So it's much more flexible. So trimming the tree or shifting the path can help you out with that. So in our case, just to keep things simple, let's go ahead and flatten this. We can ignore our tree trimming. Move this off to the side. I have a lot of things in my way here. Okay. So we're going with the nuclear option because it's going to be easier. This looks good. Everything's simplified. But what do I need it to look like? I need 1 item per branch. And that's what graft does. Now if I just click graft, it's only going to allow me to do one or the other. Now in this case, as soon as I did graft, it got rid of my flatten, but because I have the simplify on, it worked really well. If I didn't have simplify, it would have given me 1 more 0. So let's compare. If right when it starts, I have 1 branch with all those zeros, and simplify does nothing, right? As soon as I graft it, it goes from I have 4 zeros, now I have 4 zeros, and now I have a new branch for every single one, because that's what grafting does. It takes all your items and it just adds another branch. But now that I have multiple branches, when I simplify this, it gives me a nice data tree structure, and this is going to match perfectly with what I have. Which means if I plug this in, it should now work. Yeah. So there you go. So by being very careful and always checking and being aware of your data tree structures, you're able to control how often the code repeats and how it works. And I promise the data trees are going to be the thing that trips you up. And save your work often, because it's very easy to not realize that you're piping in the wrong tree structure, which means that your entire code will repeat itself many times, which can potentially freeze up your machine, forcing a restart. So now that we have this built, let's take those away. So this all came from trying to use these attractor values. Notice it was backwards. The values that I wanted to be large are actually opposite. Well, an easy way to change that is just to switch the min and the max. There we go. It's kind of ridiculous. So we'll shrink it down. Alright, very good. Now let's do it one more time, because there's one other item that we can adjust. The location along the curve. So here I put in one value. What if I want maybe the largest shades to be somewhere around maybe 0.36, but I want these little ones to always be up here? Well, I can do the exact same thing that we did before. So let's copy this remap section. So I'm taking those exact same values, but I'm going to change my values. Let's create a new number coming out. And now another hint here. This is a solid line. That means that I have one branch. As soon as it becomes a checkered line, that means I have multiple branches. So a good hint is that if I were to, say, plug in a value here, and the very thin line, that means it's just a single value. So this is multiple items, that's a single item, that's multiple branches. So if I were to take this new number and replace it, my first warning is that I'm taking a thickened line and I'm combining it with a dashed line. And if I hover over, I say, oh crap, yep, I just have one branch, multiple items, I'm going to need to graft and simplify. And I hover over, that looks good. So now when I replace this, it almost works. Why not? It says it cannot be larger than 1. This function works between 0 and 1. So if I go back to my values, this min and max is inappropriate. Let's move this down to here. And here we see that we're getting closer. And we can adjust these clip values if we want, in order to manipulate how the remapping is working. So you have a lot of flexibility in here. So let's just assume that this is what I want. We could play all day with these settings to get it right. Okay. So here I have a very complex facade using attractor points to adjust not only the size of the window, but the depth of the shade and how the shade works. I just want to point out that all of this is possible because we're leveraging some relatively basic code on a panel-by-panel logic and using data trees in order to replicate it multiple times. And then we can take very complicated relationships like the attractor curve values in order to simply update the parameters that we have. So rather than having a single parameter for each thing, we're able to pipe a new parameter for every single panel, leveraging the exact same logic. So I didn't have to copy this code 143 times. I simply pipe in 143 packets of information. And that is what the data trees are.